Okay, well today it's one of my favourite sets of all time. It's Harvard 410. No, it's not. It's Harvard 420M. 410's not my favourite set by a long way. So it's a box set. It's Mr. Farming and Trucking. We have a serial number on the box now. Harvard mic, power lead, no bracket. Might be the same bracket as the maybe the same bracket as no, it's not that one. Anyway, I better get the duster out. There we are. Very nice. Right. Well, I've got all of 10 minutes. It's Sunday afternoon between church services. I thought to make a start on this. Got so many repairs in that I'm having to kind of do it 7 days a week, because we can usually only do 3 to 5 in a week. So I've got a couple of hand portables. There's a Harrier WT1 2-channel handheld, and there's a 40-channel Moonraker Master handheld. They work quite well, but they of course suffer from being very brittle cases. Also want to do an unboxing of donations video. Right, we'll start by putting this on the standard replacement microphone. These are Cybernet wired for Cybernet radio. It'd be even better if I knew where the Cybernet mic was. Oh yes, it's on the radio behind me. Right. This cord grip's failing on this. I'm surprised with the amount of use it gets. So before it pulls all the wires out, stitching time saves 9 and all that. There's Stuart, 0SDN, calling through our repeater, GB3GR, but I'm doing this, so I'm not talking to him. It'll be all lonely. Right, switch on. Channel 20. Start off in PA. Get some boxes ticked off. These have the extra receive circuit. They have the bigger speaker. They're the same as the 420. They are a 420. Same as the Rotel 240, the York 863. Whereas you get the slightly lesser version of the Cybernet 134 chassis with the York 861. Doesn't mean they're less sensitive, or the Rotel 220. Or the Binatone Speedway, but if you're in a bleed over area it might affect that. I'm not, so it doesn't matter. Testing 1 2, testing 1 2 1 2. No PA. Have I plugged it in the wrong hole? Yes, of course I have. Testing 1 2, testing 1 2 1 2 1 2. Okay. I've already lost the pen. It's there. Back to the. I'll tell you what. We don't need the extension speaker. We'll use the instrument speakers for the next, because I know the radio's not going to blow up my test gear. We're going to need an earth because it's a radio with a floating chassis. So we'll get that connected. We're probably going to have to open the setup to get that. Anyway, we'll do the transmit first. Go to CB mode. We're on channel 20. Green displays on these. Always nice. So are we ready? What was it going to be? 2.9 watts? 5.5? Let's think. What's it going to be? Picture in picture on. We're in the 3 watt scale. It's just over full scale deflection, so it's 3.1. At least it's not being played with and thrashed. 3.1. Oh, that's not usual. 2.8. It's usually the other way around. Low power should be 400 milliwatts. It is 150 milliwatts. So go to full power and look at the current consumption. It's 980 milliamps. We'll have a quick look on here for deviation. Wallow 1.2, but we'll see about that on the other test set behind me. Frequency, let's go to frequency. Test gear's been on about 20 minutes, so it will rise a bit. Then radio's only been on, as you know, 5 minutes. We wouldn't align it until it's been on for half an hour. 2779090. So it's not really off, but we'll be able to pull it up later. So we'll dial those that frequency into the signal generator so that it's fair. It's no good putting the proper frequency in of 2779125 when you know the radio is not operating on that at this moment. So 79090. Right, that'll do, mate. RF gain to full. Tone about 2/3. Squelch off. We're going to have to provide an earth. Where can we get that from? The reason I'm struggling with this is that normally we're using it off the crocodile clips, but on a Cybernet set I'm using a leader which is on the bench with 4mm plugs on the end. So we're going to have to open the setup so we can get an earth. The speaker off. And put the earth onto that strap. There we are. Right, we will look at the SINAD meter. .33. Now they're capable of better than that. .10 dB, 0.27. Let's check the RF gains up again. Yep. 30. 0.51. So it's already working better than the manufacturer says, but I know these are usually capable of better than this. Sometimes you only, I've had Roto 240s which 0.7 is the best you're going to get, and it's in spec. But on the other hand, we then get the next one which does 0.2 something. So there you go. Having said that, does it matter? I mean, the noise floor is so great. Right, let's do squelch. Turn the squelch to 4. I'll show you the attenuator between all the wires. We'll put that to 0. We'll drop the trimming tool on the floor, and 3, 10, 30, 100 is exactly where I want it to be, 100 microvolts. And then while we're at it, we'll look at the meter, which should show S9 for 100 microvolts. It's a bit short of that. It is 300 microvolts. So that's a lazy needle, good buddy. And then we'll do the squelch sensitivity. So we'll park that and put it to standby at 0.3 of a microvolt. Turn the squelch down to nothing. Set threshold. And straight in at 0.3. So that's really good. Just for giggles, we'll see what the meter says on transmit. 4's. Oh, of course, we've now got an earth on there, and so it doesn't disconnect when we're going to transmit. It's bang on 4. Of course, it won't be when I've brought the transmitter up a bit. So we'll start by doing the VCO. So select channel 40. On Cybernet sets, this is very important. Some sets you never have to touch it. So we're looking for 4 volts on receive, resistor 4 far side. It's exactly 4 volts. And on transmit, it's 3.5. I'm not going to alter it. Go to channel 1 and check. 2.2, and on transmit 1.99. So it is within. Transmit very, very slightly out. I'm not going to alter it. So that's fine. Right. So these presets can, their trimmer capacitors can be a bit iffy now they're 40 years old. Now this is a new set, but supposing it's been stored somewhere where there's been nicotine, it doesn't smell of it. You then alter that, you turn the set back, and the set bounces because the trimmer capacitor needed changing. So while it's in its position it's in, it's absolutely fine. If we move it, it can be problematic. Yeah, so I hear you say, yeah, you could change every one. Yeah, customers would love that, wouldn't they? So there we are. It's so close, I'm not touching it. I'm just going to pull up the frequency. I know we're a bit premature to do this, but So I'll show you the frequency counter. 2779126. Obviously I'll come back to this in a couple of hours and check that that's still correct. Now we'll reset the signal generator. 79126. I'm going to do receiver first, which I don't normally do. The reason being that our friend in Leeds who does 3D printing for us, I showed you the set. He did a replica one of these sets. I've got 3 requests. I've not heard from him. So, matey at Leeds, if you're listening, I don't think you're receiving emails, and I've got 3 orders for those. He's also sent us in the last batch of Amstrad early plugs that he does for us. He did send a replacement because I've mislaid the one he made me, so he sent me some more of those, and I'm going to use it on this tune-up, but it's not here, it's in a different building. So I'll do this first, and then whilst we're waiting for everything to warm up properly, we can go back on that. So this receiver isn't as good as it should be. Let's put that earth on. There we go. Now, as they often are, I would say not what they should be, because he's doing what it should do. So we put 100 microvolts on the signal generator. We've just got that oscilloscope. Yeah, that's not smooth, is it? Something's out. So we're going to check the detector. So the detector is out for a start, but that isn't the nicest shape I've ever seen. So what we're going to do is the IF first. I'll come back to that. I'm going to go to the SINAD meter because this is what I'm looking at mainly. I need to also see the meter on the front, so we need enough signal for that to register. I'm going to turn the meter sensitivity right up. And then we'll turn this signal down, so I can only just see the meter move. And so that's nearer 12 on the SINAD meter, and then we can do the IF. The trouble is, with the SINAD meter alone, it's possible to get it the wrong side. And that's why I'm using 2 aids. I may as well start there. So look at the meter as well. That was absolutely spot on. Let's go for this one. That was absolutely spot on. What about the one under the wiring? That wasn't absolutely spot on. Let's look back at the 100 microvolts. Go back to the oscilloscope. Go back to this adjustment, to the detector. So it's now the right shape. So it was that one under the wiring that wasn't right. I don't think this is a return. It's not out enough to be a return. This looks just a set that's been harboured. Now then, let's go to the SINAD meter, do the front end. Just take that down a bit so we've got an even lesser signal down. It's about 4 microvolts. Sorry, 0. Start again. Down to about 4 dB. Oh, hey, that's coming up. That was alright. And that was alright. So that's the receiver done. So let's see if we've made it better or worse. There's quite some things amiss. So we've got the detector out, that IF coil out, and that front end one out. Everything else was alright. Here we go. Get myself on the right scale. 12 dB is now 0.21. That's the kind of thing you expect from these sets these days. It's just under 0.2. I'm between scales, so we'll put down 0.2. And then for 20 dB, that's where your clarity is. It's actually 0.36. So this may have been wrong from factory, because they're given, what, 10 seconds to do all this. Dum 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 dum. All they have to do is to make it go to a pass mark on a meter. They didn't have SINAD meters, they didn't do it that way. So, you know, 10 seconds on the conveyor belt, 10 seconds on the conveyor belt. We can spend a lot more time. Right. Okay, so squelch, this will now have altered. Squelch to full. So I want 100 microvolts to open the squelch. Did before, what will happen now? 30, 10, 20, 30, no, still 100. Spot on. So what about sensitivity? It was already spot on. It's 0.3, exactly the same, so that's great. Now I've messed with the meter, so let's put that right. 100 microvolts on the meter. Oops, tools out. Bring that down to 9. There we go. So the squelch is under there. We don't need to touch it. So that, I'm going to start the transmitter, then we'll leave it for about half an hour. I'll go and get the other tools, and we'll the deviation meter behind me will then be warmed up properly. So we'll just start with transmit, and we'll just disconnect that earth. So we're still at 3.1 watts. I just want to make sure it's centralized. I'll show you on the main meter. That's perfect. That is get the tool into there. Not quite. We're still at 3.1. So we've just got those 3 to do, and Bob's your uncle. So I'll see you in about half an hour. Right, so I'm back with you all, and this is one of these trimming tools put against the white background, which Matey has made for us. So if you'd like to check his emails, because I'm not getting any responses. Right. Are we on the right meter? Yes, we are. So we need to have maximum on this one. Which is there. maximum on that one, maximum on that one. Now we'll just check that we are at maximum. Now I'm going to check that this one's at maximum. Clockwise for 4.4 watts. Anti-clockwise for 3.8 watts, except we're not going to do that, we're going to leave it at 4. Right, see what we've got on the other channels. It's absolutely spot on. If you ever come across a set that's doing more than 4 watts, it's very important to go through this thing, that you maximise it and then drop it clockwise and anti-clockwise for the 4 watts. That's clockwise for 4.4, anti-clockwise for 4, though the manual says 3.8. Because, legality aside, these 1, 2, 3 and the one down there melt if it's much more than that. And you're not going to get replacements except by smashing up another identical set, are you? Right, low power. I'm on the wrong setting, there we go. Absolutely fine, doesn't need cleaning. They often get dirt in them, but this one's been stored such that it hasn't got dirt in it. So that's really good. So now we're going to check the frequency, because, if you remember, 2 hours ago when I set it, things were still warming up. So we want to look at the frequency. Yes, it's high, you see now. I'll go back to channel 20, of course. We'll just pop that back where it should be. Just leave it very, very slightly high because they drop with age. So that gives us 2 things to do. Check the current on transmit. It's now 1.186. 1.186. So we've gone up 200 milliamps and generated another nearly 1 watt. And finally, I want to check the deviation on the meter behind me. We were reading 1.2 on this one. Sometimes it's lies, because it needs the capacitors doing in the deviation meter section, and it's never going to have it done. So I want that to central position. That's the feedback one, which you don't get on the European version of these sets. Don't know why you get it on these either. Wow. It's now 1.8, or was it there before? It was, wasn't it? Let's try and not stretch it too far. Wow. There we go. Peak of absolute peak of 2.5. I'll only test the mic that's come with it on the air test. So it was actually 1.8. It's now 2.2 to 2.5. So we need to do the meter. meter, when we press transmit, we want it to be 4. Of course, we're on the other test set, aren't we? Banging across, and that needs to come down to read 4, which is there. And remember, these are relative power meters, so if you put it on an aerial, it's only going to read 4 if it's a perfect SWR. So when we do the on the air test, in fact we'll put the aerial on right now and see what it does read. When we do the on the air test, I was going to say it might read 2, it might bang across. It doesn't mean the radio's doing any different power, because it isn't. People seem to think these meters tell the truth. Mind you, it's better than the current models where the meters don't tell you anything. Just pre-programmed. So we're on the aerial now. Let's see what the meter does. It actually reads bang on 4, but that should be a good SWR. Right, we'll put the lid on that. That's worked out a really nice set. You get the bigger speaker in these, and you do this. Fidelity 2000 has the bigger speaker. These have the bigger speaker. The Binatone 5-star has the bigger speaker, and the Harrier CBX. And to my recollection, none of the others have the bigger speaker. It's possible the SMC Oscar does. So you're getting the high spec version of the Cybernet 134, but without all the pointless knobs that you get on a York 863 or a Rotel 240, etc. These were £89.99 at the time. Then of course Harvard went and spoilt it by producing the Good Buddy, didn't they? Up to that point they were all nice sets. So the transmitter was doing exactly what you'd expect for a set out of a box, which has never been fiddled with. But the receiver detector was out, one of the IFs was out, one of the front ends was out. And you think, why is that? I don't think this is a return, but it certainly will now work so much better. So, one and a Roger. Somebody got a bleep for Christmas, but they're actually over deviating. Right, we'll be doing an on the air test with this. Yeah, I'm going to turn the volume. That's so annoying. That's probably why they're doing it. They're wanting somebody to comment, aren't they? These people can't get anybody to talk to them. Right, so there we have it. The Harvard 420M in a box. thank you for watching, and our next repair will be a Moonraker Master hand portable.